Hey, it's Joel. Boy, am I excited because I get to build something using 3D printing that I've wanted. I've wanted this for so long. I've seen tons of other creators have these amazing hexagonal LED lights in the back of their studios, the back of their shots. And I've always wanted that. And I've always thought I'm not gonna go buy it. A, it's expensive. And B, I could make it myself. And then I never set forth the time to do that until today. Where are my manners? Welcome to 3D Printing Nerd Studios, proudly powered by PCBWay, PCB, CNC, and 3D printing. It's all at PCBWay.com. And PCB and 3D printing is what we're doing today. First, let's talk about the project at hand. This is by user MERT KILIC, and it is a PCBWay community project. And this wonderful human put together a hexagonal LED kit. This kit makes it easy for you and me and everybody who's kind of excited at the prospect of building one of these things for themselves to be able to do it. And the parts list is actually pretty minimal. You can get into the weeds with this stuff, and boy, howdy would I like to, but you gotta start somewhere, you and me and everybody, and we're starting here with a simple strip of LEDs, a power supply, and an 8266. Wait a minute, you need the 3D printed parts. Let's move these to the side. They also provide the 3D printable parts, both the brackets to hold the lights and the diffusers. So the bracket, well, here, I got them right here. It's a bunch of hexagons. I print a lot of them. Hexagons are besticons, and they print like this, and they've got a whole hole and a whole hole. So the idea being, you could do this, you could do this, and then you could do this. So this lets you route LED cable throughout all of them without doing any cutting or soldering.
Genius.
And that's what makes a kit like this really accessible to everybody. This is Prusament Galaxy Black PLA. I love it, and it prints great, and it was printed on the Core 1L behind me, which is where the diffusion is being printed. Let me go get it. Here are the diffusion pieces, some more hexagons, and here they are on the build plate. It probably makes them a little bit easier to see. This is using Printed Solids Jessie Natural PLA. I thought I could just use a white PLA or PETG, but I wasn't sure if the lights would be able to shine through it. Again, I haven't done a lot of LED projects, so the natural PLA without any pigmentation in it would provide what we need, and then we can always adjust. It doesn't take much filament to do this, but let's break it off the build plate. Ready? The idea of these, really simple. Because there's that little lip on the inside, all you gotta do is put that in like so, and there you go. Look at that. You've got a back side where you can put the lights, and you got a front side, you can have the diffusion.
You bend and snap.
And that means you can swap out the diffusion for a solid white or a semi-transparent white or a natural or whatever have you. So I'm gonna follow along with what they've put in the community page here. They use hot glue to connect everything, and hot glue is great, but I'm using PLA, and so I should just use my 3D glue because it works really, really well. These are all glued up, and 3D glue doesn't take forever to adhere initially. You do want to give it a 24-hour full cure before you do something, but I mean, at this point, we've got, I mean, it's pretty good. It needs to fully cure, but we're good to start running LEDs through. You have to stake it through and then remove the adhesive to put it around the edges. Start it this way, we'll slide that through. We've done it. We've literally done it.
You did it!
When you get to the end, if there's LEDs left over in your strip, you just cut along the little area in between the LEDs. You just snip it. There's even a line there you can pay attention to. Dunzo. There we go. We now have LEDs. The next step for this, let's put on the diffusers. Diffusers. I'm gonna tack these in with just a little bit of glue. Before we install WLED to this, let's connect up power and let's connect up the lights. The lights come with a little pigtail, and power from that power connector comes with one of these, and you can attach wires to it to be able to tap into this. And what's really cool, from PCBWay, when it's pre-assembled, you get the light side and you get the power side. And the light, here's what's really good. You've got plus 5 volts, you've got GPIO 12, which is what this is configured to use, and then you've got ground. And on the pigtail, plus 5 volts, GPIO 12, and then ground. So you could just slide those in, tighten them up, all in a row. Little tug test. Good. On the power side, you've got plus 5 volts and ground, and I happen to have plus 5 volts and ground. So let's get this plugged in into the lights. Now, they're not gonna do anything yet because we haven't installed anything. This is just a microcontroller. It doesn't know anything. And that's what WLED is. It's a program that runs and burns into the microcontroller, which tells it how it can do things. This is the WLED installer site. And what you do is you plug your cable in, and then you pick, I'm gonna pick plain, and I'm gonna do install. And it's gonna ask me what it is, and there's my UART. So, boom, it's connecting. And I want to install WLED, erase device. That's totally fine because there's nothing on there, and install. And I can see a tiny little blue light going, which means it's erasing. Now it's installing. And at this point, get something to sip on.
A few moments later.
Installation complete, look at that, with all sorts of fanfare. So then you click next. It's gonna scan for networks, and I'm gonna connect it up to my Wi-Fi here in the studio. Cool, visit device or add to home assistant. I'm going to visit the device. Skip reporting. And this is WLED. What we need to do first is tell it what we have and how many we have. So if I go to config and LED and hardware, this is the right LEDs, but it says length 30. I'm just gonna put 500 and maximum PSU current. So this, I believe, can put out more than 850 milliamp. I think what I'm gonna do is jump it up to 2000 because I'm not just running off of a standard USB port off of a computer or anything. This is a dedicated power supply. I know we can sustain that. And then I'm gonna hit save. And now if I just go solid power, maybe I don't have the right LEDs. The reason it's not working, and something that I just completely forgot, is in the instructions, it is listed to use GPIO pin 12. It actually says it on the board, it says it in the instructions, and I forgot within the settings of WLED to do that. It says data GPIO 2. Let's change that to 12, and let's save it. There we go. All LEDs on. So here we go. So within WLED, we can go back and we can do things. Neat, right? So WLED, fully extensible, but also you can access it via programmatic methods. And knowing that this is a community project, I thought, what's a way that I could contribute? So I created an application called HexHive. Within HexHive, the idea was I wanted an easy interface to communicate with WLED, because WLED is powerful, but the way to talk to it is a little bit difficult. So watch this. So within HexHive, I'm connected to the IP address. What I can do is tell it that I've got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then what I can do is down here in the layout designer, so let's put this together. So we'll do it like this, just like that. So now we have it kind of laid out the way that we want it to. And this is where it starts to get really cool, and I think why I developed this, because let's say you need to count the number of LEDs. I just put in a random number of 500. What I can do is hit this Count LEDs button. Initially says 250 because WLED is reporting 500 LEDs. So it says the 250th LED should be illuminated. It's not. So let's step back. Oh, there's one. Now it's saying 225, 48, 49, nothing. Okay, so 249. That's the LED counter that I put into HexHive. So LED 249 in a zero-base system is LED 250. Now that we have the correct number of LEDs, what we can do are some pretty fun effects. So how about this rainbow flow or cyber pulse? There we go, or a honeycomb. That's kind of cool. So I've pre-programmed these into HexHive to be able to do some really fun stuff. So now if we go into map LEDs, there we go. This is LED position 0, and this is going to be in number 1, which is what we have. So what we can do is advance the start. That's going to be the first LED within that one. So I say confirm start, and then I can just walk. Okay, oh, nope, back one. There we go. So now I can save. Now I can say, oh, I need to add a range to that. So if I walk it around, there, it starts there, and back one. And there we go. This allows me to map what LED segments belong to each of the hexes. So let me get the rest of them done, and then we're gonna do something really cool. That took a little while, but we got it. And again, it's software, it's gonna have bugs. I wrote it. It's gonna have lots of bugs probably, but it works. And we were able to map each of these hexes to individual strands of the LEDs, which is very, very important. So now we're going to push to WLED. Now what we can do, let's go over to hexes, and we can individually pick a hex and paint a color. Boom, boom, boom. And then red. Oh, I can't believe it's working. This is so cool. We did something amazing today. We put together LEDs and then we're able to install something and then do extra stuff with it. So this is a PCBWay community project. I'll put a link to it down in the description because it's a ton of fun. And huge thanks to MERT for contributing this project because it got me interested in LEDs again. If you yourself are someone that is well suited to the RGB LED game, I would love some tips and tricks and pointers to everything because I would love to have the skills necessary to be one of those houses at Christmas time. Absolutely. And my software, HexHive, I used Claude Code and my knowledge of software and kind of how to structure things. HexHive is something I'm just gonna release, and I will put a link down in the description. It'll be in my GitHub, and have at it. If it works for you, great. If it inspires you, great. If it makes you do something that you didn't think you'd do before, great. I'm excited about this, and I wrote something, and now I want you to be excited about it too. A huge thanks to PCBWay for sponsoring this project. Links to them, of course, down below, and a huge thanks for them powering the studio. We got more projects coming from them as well. I can't wait. If you made this fire awesome, don't forget to hug each other more, fight for a cause you believe in, LED all the things, and as always, high five.